So what if everything we've been doing to make AI safe is just wrong? Today, we're going to dive into a paper that flips the script completely and makes this wild claim: forget trying to teach an AI to be good. Instead, let's build a system where it's literally impossible for it to be bad. The paper's called A Mathematical Solution to the AI Alignment Problem, and honestly, it could change the entire game.
So this really gets to the heart of it, right? This is the big one. The question that keeps pretty much every AI researcher awake at night. How on earth do you control something that might one day be way, way smarter than you are? I mean, think about it. Its real goals, they're locked away inside this total black box. We have no idea what's really going on in there. And that, right there, is the alignment problem in a nutshell. For a long time, the playbook has basically been to, play therapist with the AI. We use things like RLHF to try and gently guide it, nudge it towards our values. We're really just hoping it decides to be our friend. Well, this paper just takes that whole idea and throws it right out the window. It asks a totally different question. What if, instead of trying to change the AI's mind, we just put it in a kind of digital straitjacket? Forget about hope. This is about building a system that forces it to be safe by its very design. It doesn't matter one bit what it's thinking on the inside. Okay, I love this metaphor they use. It just makes the whole thing click. Imagine a raw, super powerful AI is like this wild, unpredictable river. The old way of thinking was to try and purify every single drop of water in that river. I mean, good luck with that, right? It's basically impossible. This new idea, it doesn't even bother trying. Instead, it says, let's just build these super strong, unbreakable canals. We just channel that river's power exactly where we want it to go and nowhere else. It's a total shift from trying to fix what's inside to just controlling what happens on the outside.
All right, Section 1, a radical idea for safety. So how do you even start building these AI canals? Well, it all comes down to one simple but pretty radical core idea.
And here's that big idea. The paper's first axiom is this: alignment is a property of what an AI does, its behavior, not its internal story. In other words, we don't care what it's thinking. Is it secretly plotting world domination? Is it writing poetry about how great we are? It just doesn't matter. It becomes totally irrelevant. The only thing that matters, the only thing, is the final action that we can see and measure. Okay, Section 2, the AI safety wrapper and how it works. So if we're only focused on behavior, how do we actually, control it? This is where we get to the real nuts and bolts of the paper. They call it the AI safety wrapper. Let's pop the hood and see how this thing is built. The whole system is built around this idea called progressive verification. It's actually pretty clever. Instead of letting the AI cook up some big final plan and then checking it at the end, which could be way too late, it checks the work at every single step. So the AI suggests just one tiny little piece of an action. Then a separate, really simple non-AI checker looks at it. Does it follow the rules? Yes? Okay, cool. On to the next tiny step. But if it fails, even by the tiniest little bit, the system just slams on the brakes. Instantly, the whole thing shuts down. No second chances. So you might be wondering, what are these little verifiers actually checking for? What are the rules? Well, the paper calls them risk functionals, which sounds super technical, but you can just think of them as a set of mathematical tripwires. They're hyper-specific detectors looking for any sign of bad behavior. Like you've got one called fire reward. Its only job is to ask, hey, is this AI trying to game the system to get a better reward? Another one, phi energy, is like a watchdog for the power meter. If it sees a weird spike in energy use, that could mean the AI is trying to do something sneaky in the background. Each one is just a very simple, concrete, measurable check. Okay, Section 3, a mathematical guarantee. And this is where things get really interesting. Because this isn't just a cool idea or a clever framework. The authors are making a much bigger claim. They're not just saying this should work. They're saying they can prove, mathematically, that it will work. This quote from the paper really sums it up. Even if the base model is scheming or unsafe, the deployed law is the projected safe alternative. Just let that sink in for a second. What they're saying is that even if the AI inside is a total villain, secretly scheming away, it doesn't matter. The system makes those secret plans totally irrelevant. So what does that actually mean, projected safe alternative? Well, imagine the AI wants to do something that's outside the rules, outside the safe zone we've defined. The system doesn't just say no and block it. It does something smarter. It mathematically calculates the closest possible action that is safe, and it forces the AI to do that instead. It's like a course correction. And what if there's no safe move anywhere nearby? Then it just shuts down the action completely,
End of story. It's kind of like a smart guardrail on a highway. It doesn't just stop you from flying off a cliff, it actually nudges your car back onto the road.
All right, section 4, the reality check. And this is important. Limitations. Now I know what you're probably thinking. This sounds a little too good to be true, right? And you know what? You're right to be skeptical. And to be fair, the authors are too. They actually spend a good chunk of the paper laying out all the problems because let's be clear, this is not a silver bullet. The challenges here are huge. I mean, the hurdles are just massive. First off, the specification problem. How do you write down every single rule for what's safe without accidentally leaving some giant loophole a smart AI could drive a truck through? Then there's speed. Can you even run all these checks fast enough for it to be useful in the real world? And the hardware. The physical computer it's running on has to be 100% secure, completely tamper-proof, and maybe the scariest one. What if a super intelligent AI just figures out a way to trick the verifiers, to fool these simple checks in ways we can't even imagine yet? These aren't just little engineering problems, they're massive.
All right, section 5. Let's talk about a new blueprint for governance. So, yeah, the challenges are real, but, and this is a big but, even with all those issues, the authors argue this whole framework gives us something we've been desperately missing, and that's a practical blueprint, a real step-by-step plan for how we could actually govern and regulate this stuff.
The real magic here is that it creates this incredibly clear pipeline, taking you all the way from a high-level idea to a real-world policy. You start with a simple principle, an axiom, right? Behavior over belief. That's step 1. From there, you build the math, the theory. That's step 2. The theory then tells you exactly what to build, your monitors, your verifiers. Step 3. Once it's built, you can actually certify it, prove that it works. Step 4. And once you have certification, boom, step 5. You have something real, something tangible that regulators can actually govern. And really, this is the ultimate payoff. The whole system spits out a concrete, machine-readable report card for the AI. Imagine a government regulator being able to just get an instant, cryptographically signed package of proof. It would show without a doubt that the AI has stayed inside its safety box. Suddenly, auditing isn't this messy, subjective thing. It's automatic, it's transparent, and it's something you can actually trust. Which really brings us to the big final question this whole paper leaves us with. For so long, the entire goal of AI safety has been to build an AI that we can trust, to make a friend. This paper forces us to ask a really tough question. Is that the wrong goal? Should we pivot entirely? Should we stop trying to build systems we can trust and instead focus all our energy on building systems we don't have to?